talk about the domain of a rational expression. So the domain, those are the things that we're allowed to plug in that will give us something nice coming back out. And by something nice, I mean a real number. So when we're talking about the domain of a rational function, we have to be careful because we're talking about a fraction. And fractions have certain rules. One rule being you can't have division by 0. So we just need to make sure that when we're talking about our rational, p of x, there we go, over q of x, when we're talking about our rational expression, one thing about it is that q of x cannot equal 0. We call that a restriction on the domain. So what we want to do is we want to figure out, okay, what is x not allowed to be, and then we can work with that to figure out that, well, it can be everything else except for that particular value or values. When we're talking about the domain of an expression, we're talking about the domain of the thing that we're given. So we do have to be careful there. Okay, so what's going to create zeros in the denominator? Let's see. So we're going to state the domain, and we're going to write it in interval notation. For letter A, we have 2 over x. So what's not allowed? What's not allowed is that x cannot equal 0. That's it. All done. That's the restriction on the domain. We do need to write it in interval notation. How do we say it can be any real number, but we need to pluck 0 out of it? Well, that would go from negative infinity to 0, and then start back again at 0 and go to positive infinity. So that's how we write the domain for letter A. Letter B, we have 3x plus 1 over x squared minus 25. Again, the restriction on the domain is when the denominator is equal to 0. So we say, okay, x squared minus 25 cannot equal 0. And now what we want to do is we want to figure out what's going to create those zeros. Where are my restrictions? What I would do, since x squared minus 25 is a difference of squares, we can factor it into x minus 5 times x plus 5. And then we can say, well, x minus 5 can't equal 0, in which case x can't equal 5. And x plus 5 can't equal 0, in which case x can't be negative 5. So here we have 2 restrictions on our domain. X can't be 5 and x can't be negative 5. The way we write that in interval notation, we're going to go into all the real numbers and we're going to pluck out negative 5. But it can be any number between negative 5 and 5, and then from 5 to infinity. So we have to include every interval of numbers around the negative 5 and 5. So that's numbers smaller than negative 5, between negative 5 and 5, and the numbers bigger than 5. And that's our domain for letter B. For letter C, what's not allowed? X squared plus 4 can't equal 0. X squared plus 4 cannot equal 0. Well, we want to see, okay, what values for x are going to create a 0 there? Well, x squared plus 4 actually isn't factorable. It's the sum of squares. And in fact, it's never going to equal 0. In fact, it's never going to be smaller than 4 itself. So we don't have any restrictions because we never have to worry about the denominator being 0. If you want to verify this further, it's not factorable. So you can say, okay, x squared can't be negative 4. And again, there's no real number that when you square it is negative 4. So we have no restrictions. So letter C would be negative infinity to infinity. In letter D, we have x plus 2 over x squared plus 5x plus 6. We want to factor the denominator, well, x squared plus 5x plus 6 cannot equal 0. To see what's going to create those zeros, we want to factor it. It's going to factor into x plus 3 times x plus 2. Cannot equal 0. Now, you might notice here that there's a factor of x plus 2 in the numerator and a factor of x plus 3 in the denominator. So can't we simplify it out? We can, but not when we're finding the domain. When we're finding the domain, we need to use the original denominator as it is. So now we see that the restrictions, x can't be negative 3 and x can't be negative 2. So how do we pluck out negative 2 and negative 3 from from the real numbers? We would say it can be anything from negative infinity to negative 3, from negative 3 to negative 2, and from negative 2 to infinity. And that would be the domain for letter D.